don't you subtract the top
Yes.
graph from the bottom graph?
Yes.
How do you know which is which?
Not only do I not see which one's which right now, I don't even see where the A's and B's are going to be. So to answer your question, Reza, I think I have to take a break and apply my math D skills and graph these things first in order to determine that. So everybody, as he just pointed out, yes, David.
What if the your graphing capabilities aren't as swell as some other folks, and you just wanted to do that algebraically? Would you be able to just?
Well, you know, good point. I mean, you could apply your math 30 skills and look for when the function's increasing and decreasing. Maybe discuss concavity.
Okay.
And, oh, yes. Put it all together. You wouldn't want to use a graphing calculator,
No?
That's too clunky. The batteries run out. You might get in trouble. If you're on a deserted island, you wouldn't do that anyways, right? You'd do it by hand. What's that?
The first one's the first one.
Now that makes me a little nervous. What you're saying is correct. As long as you integrate the thing, then you get the inverse tangent. But what about this thing all by itself? X-axis, Y-axis. Do you guys have a feel for what this thing might look like? Well, 0, 1 would definitely, certainly, right away be the y-intercept. What else can you say? Just true. Can I skip that for a minute? Because I want to concentrate on graph on this first, and then we'll go to the intersections. What else can you say about this graph? As x increases, are the y values going to increase in the right-hand plane?
No, it's going to approach.
No, I think they're going to decrease. And I think if I took the limit of the beast as x increases that bound, it's going to go to 0. So I think somehow this curve is going to behave, I don't know, something like this. But now on the left-hand plane, what do I do? Up or down?
Neither.
Yeah, how about neither? Why not be lazy? I mean, at a glance, isn't that equation representing a function that's an even function? Remains unchanged when x is replaced with negative x. Can we just cheat? Symmetry respect to the y-axis. Next, you got me spoiled with an eraser on this thing. Next, that graph is going to be a, you guys, a hyperbola, which is nothing more than y equals 1 over x, a standard hyperbola, but shifted 1 unit to the left, and therefore, I think I got my vertical asymptote right here. And I think the graph looks something like this. Something like that, I think. Maybe, maybe not. Do you think there's a region bounded by these two curves? Yeah, I think so. You guys, I might have done a poor job asking my question. I think it's okay the way it is. But I guess I could clarify it more by saying, determine the area that's bounded by the graph of these two curves. And I think the only region bounded is over here. No. I think the only bounded region is over here. I think to the left of that point of interest, that's an unbounded region. Do you see my point? So, I guess I got to take another break. As suggested, I need to take a break and find points of intersection. Let's do it. To find out where these two curves intersect, I know one's obvious, that x equals 0, but algebraically, I will take the output of one, the output of the other, and set them equal to each other. Yes?
So for the first one,
Yes?
wouldn't it be approaching 0 faster than the second one because it's x squared?
You know what? I think you're right. For values of x at a certain value, it's going to get to 0 faster. But I think initially, when x is less than, say for example, 1, I think it's maybe less rapidly going to 0 than this one.
Oh, okay.
And you know what? Maybe I'm wrong. And if I'm wrong, I'll find out the answer over here.
Okay.
Let's clear fractions. Let's subtract 1 from both sides. Let me test your math D skills. What's next? What's next?
Divide both sides by x.
That makes me nervous. Because if I divide both sides by a variable expression, I might be dividing by 0. I might lose one of my solutions. Do you see my point? Now that's nice. This is a polynomial equation. Let's set everything equal to 0. Then what? Factor. Then what? principal of zero product says x is 0 or 1. And therefore, here's one point of intersection, and here's another. Okay, so I'm off scale. This point of intersection has x coordinate positive 1, but a y coordinate of, where'd you get 1/2? Which one? Doesn't matter, because it's a point of intersection, they have the same y values. And you can check both of them if you want, they're both 1/2. Now that I know what region is being bounded in green, I can set up my integral. So I think the area in between these two curves is nothing more than the valuation of the integral. As x ranges from, what is it, 1/2 to 1?
0 to 0.
No, it's the x coordinate of the one of the point of intersection left to the x coordinate of the point of intersection to the right. And by the way, that allows me to look at what's in the integrand's position as, I don't know, anybody?
1 over 1
1
plus
over.
x squared
1 plus x squared.
minus 1 over 1 plus x.
And I'm integrating respect to x. Now we will have the inverse tangent, yes. By the way, help me with this one. How did you know that came first?
Because it's on top.
Because on top, but it's because on top because I drew. You guys know I can't draw well. How are you sure this is on top?
Because from 0 to
Well, I think you just plug in a number for x. Somewhere between 0 and 1, like 1/2. And if you plug 1/2 in for x, you'll find out this one's larger. Yes, sir.
It's going to be a bit more tedious, but if you get a negative answer, would that also maybe tell you that,
You know, what a good point. If you get a negative answer and you made no mistakes along the way, that means you did have a reverse. Yes, I agree. But you know, you could have got a negative answer by making some other silly mistake along the way. So are you guys ready to combine fractions? The LCM is...
Don't combine it.
Yeah, I think too much work. Actually, why don't you and I, in this example, just split up these integrals? Only because life is so darn easy. I think at a glance I can anti-differentiate these two expressions in these two integrand positions. After all, in the first case, I get the natural log of what?
It's inverse tangent.
Nothing. I get a natural log if I had a factor of x upstairs, but I don't. Actually, straightforwardly, like Randall was saying earlier, just the inverse tangent function. P value on x, ranging from this x value to that x value, minus, do you think we could write this out without making use of?
We should probably do the use of.
What is it, just natural log of, you said? The natural log of,
1 plus x.
how about 1 plus x? As x ranges 0 to 1, I know I should have absolute value bars in here, you guys, but over this interval, it's strictly positive. That being the case, let's evaluate it.
Pi over 4.
Pi over 4. Minus natural log of 2.
Yeah.
Are you happy? Oh, by the way, on the quiz, maybe I just didn't have it clear on the board, but a lot of you are just diving in and using your calculators. Expect me to ask you this for the most part, for exact values only. Anybody? My first example, any questions, David?
I don't see a natural log of 2. I mean, how, where?
I skipped too much work. Can I put it in?
Yeah.
I've got this antiderivative valued at the upper bound, minus this antiderivative valued at the lower bound, minus this antiderivative evaluated at the upper bound, plug 1 in for x,
I see.
minus this antiderivative at the lower bound. It's just that, that's a pretty number? That's a pretty number? Okay.
No, I just thought 10 inverse of
Yeah, it had nothing to
0
do with
was
that.
natural log of 2. I'm like, how does that work?
No, I didn't mean that.
Okay, that's cool.
Anybody else want to attack me on this? Sir?
I know that this is the easier way to do that, but could we use the substitution and substitute 1 plus x as u?
Yeah, do you want to see me do it?
Yeah, well, it'd be the same, it would end up being the same.
It would definitely be the
Okay.
same. Absolutely.
I mean, this is obviously easier.
I was just doing
If
the
I
use of
happen to forget the inverse.
Yeah, just commit to the use of it, it'll get you out of the trap. guys just talk? Say something, just panic, say something.
Grafton.
Yeah.
Graph the darn beef. The first one's aligned with what kind of slope? Well, it's not a line, clearly it's a parabola. Well, the other one is parabolic as well. I was just looking at the first one. Did I think it'll be an upwards parabola? And I think it looks something like this. X-axis, Y-axis, vertex at the origin. Good, it's not at the origin. Slightly bigger. Can I be this lazy? And the other one is, use words. The other one is, but use words. The graph looks like a, the graph is a, half of
A
a,
sideways
I don't
graph.
know what that graph is, but I know what a square root graph is.
so it's half a parabola.
Yes.
That opens up to the right, like you're saying. Vertex at the origin. Maybe it looks something like this. Oh, you guys, I apologize. I should have labeled these more carefully. Is that 115? Plus 14? Got it. Well, at least I hope it looks like this. At least I hope there's an overlap, so I get a region right here bounded by these two curves. And if there is, then let's compute the area. Because I think the area is going to be computed by simply looking at the integral from shoot, I can't do
You have
this.
to find points of
Yeah,
intersection.
I don't know the points of intersection. I have to take a break. I need to pull out a nifty piece of scratch paper. I need to take the output of one. The output of the other, and set them equal to each other. I can wait. Square both sides. Oh, if you insist. I'll do whatever you want.
Shouldn't we, in the first step, have multiplied x squared and 14 by 115?
I could have just as easily. I got so many ways to solve this equation.
Like when we equal to 0, multiply both sides by 225 and expand x squared plus 14.
All right, if I expand this binomial squared, does that give me x to the fourth plus 28x squared plus 14 times 14 is 196, being equal to 225x. What next?
Subtract your 25 and set equal to
Subtract 225x from both sides. Nope, hold it, I made a mistake. That's minus 225. You guys just don't want to play today.
Do synthetic division.
But what do I use in the box?
You gotta find your P's and Q's.
You gotta find your P's and Q's. You get those from
The,
shoot, what was that called? That was called the rational root theorem. The rational root theorem says this: if this Polynomial expression left-hand side does indeed have a rational zero, it's going to be of the form P over Q, where P divides evenly into the constant term, and Q divides evenly into the coefficient. And you and I can use synthetic division to whittle away at the process. Are you ready? Let's try box. Let's try 4. So how do I start the process?
You missed one.
Good, I don't start it. I think I've got to place a coefficient for each and every term in that polynomial from 4 down onto 0. So I think the coefficient of x to the fourth is positive 1. Coefficient of x cubed is
0.
0. Coefficient of x squared is 28. Coefficient of x is negative 225. And the constant term is 196. That being the case, I think I'll drop the first entry, multiply, add, multiply, add. You're making me do all the work. Multiply. Add, yikes. You got me? And then multiply. And then add. Oh, hold it, I can't. I made a mistake with my signs. And then add, and what do I get?
0.
0, how nice. That being the case, I recognize that this fourth degree Polynomial expression can be re-expressed as x minus 4 times a trinomial whose coefficients are here, namely an x cubed plus 4x squared plus 44x minus 49. Yes, I'm listening.
Would it be completely wrong to, on the top equation right there, the where it's still x to the fourth, if you just subtracted the 196 and then factored out an x, would one of the values of x be 196, or is that completely out?
Unfortunately not, because if you were to play that game, you would have had this x times x cubed plus 28x minus 225 being equal to negative 196.
Yeah.
Now check this out. Since the product of what's above my arrow and what's above my brace is equal to negative 196, it doesn't mean that one or the other is equal to negative 196. That's why it only works when you got 0 on the right hand side. So we do have something called the principle of zero products, but we don't have something called the principle of negative 196 products. No, it's a good question. That was a really good question.
How did you choose 4?
I made it up in my head. You know, I knew if this particular Polynomial expression inside the black circle had a rational 0, it's going to be of the form P over Q. Sir, before I finish, do you understand what I mean by rational?
Ratio.
Yeah, when I talk about a rational number, I'm talking about a number that's the ratio of two integers, a fraction. So I'm saying, here's the biggest word in mathematics. I'm saying if this Polynomial expression does have a rational 0, it's going to be the fraction P over Q, where P divides evenly into the constant term, which would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus, a lot of choices, up to 196. Q divides evenly into the coefficient out front, but that's just a positive 1, it's just going to be one of these two. And I got to choose one. And I'll be honest with you, I just glanced at this and I thought it was going to be some number in the 4 range, because I'm seeing how these things jump from one to the other. I got lucky, I really did get lucky. Now, I'm not done. Shoot, you guys, look. There's 2 points of intersection. If my picture's accurate, I guess it's going to be another point of intersection. But it looks like this one's going to be smaller than 4. Like a 2 or a 1. Actually, 1's easy. Can I try 1 first? Let's see if 1 works. Pumping 1 through the 1, 4, 44, negative 49. If it doesn't work, I'll try the 2. Drop, multiply, add, multiply, add, multiply. Oh shoot, how nice. Now I see this Polynomial expression factors further into the product of x minus 4, x minus 1, x squared plus 5x plus 49, being equal to 0. Now playing the game one more time. 1, 5, 49. Anybody have an idea what works?
Can you just
Nothing.
Nothing. That's
How do I know that so fast?
because that just
It just
it just can't factor.
How do you know that?
Just looking at it.
No,
But how can you just look at it and say it doesn't factor nicely?
it's just
Well,
no
because
factors
it's
of 49, they can
yeah,
just sum together
it's
to
7
get
and
5.
7, and that's all you can do with 49. So that you can't get 5 out of that.
Okay, I was hoping you guys were saying this.
this?
Thank you. Because the quadratic formula, since it's quadratic, the quadratic formula has a square root of b squared minus 4ac. And clearly at a glance, b squared minus 4ac is very negative. And so I think this quadratic factor is only going to yield non-real complex solutions. And even look at my picture, that makes a lot of sense. There really should only be 2 points of intersection. One is at
4.
1 comma, oh, you said 4? So
Yep.
4 comma, oh, 2, that's easy. One's at 1 comma 1. Well, I guess I've answered my own question. Those bounds of integration are going to be 1 or 4. The function upstairs is going to be root x. The one downstairs is going to be this. Ah, I can't write it, sorry. I want a yes or no answer. Is that a piece of cake to evaluate? I said I want a yes or no answer. Is that a piece of cake to evaluate?
Yes.
Yeah, it is. And because it's a piece of cake, do you mind if I don't? I think the last one was more interesting. But since you can integrate this easily, can I just not go through the arithmetic? Okay, thank you.
On a test, like for this example, just based on the way the shape of the graphs, you kind of know that root x has to be on top, because if the quadratic equation was on top, then it wouldn't overlap.
Thank you. There wouldn't be any point of intersection.
So like, if we see something like this on test, do we have to go through all that, or can we just infer?
Well, what if he does a trick question and they don't overlap and the answer is there is no boundary?
You know, on a test situation, I will never trick you that way, but on the other side of the coin, on a test situation, I might have nice enough curves to where those points of intersection aren't immediate. You have to go through the algebra. I'm in front of class. I'm trying to beat that clock. So my points of intersection have really nice clean x-coordinates.
So you won't be able to plug in any x value until you know the actual bounds, because if you plug in something that's out of bound.
You might be out of that bounded region. You're right. Good point. Yes, sir.
I don't still get how you get 4 or that 1 where you go through that process of,
Before I answer your question, do you see where these numbers came from?
yes, they're just the code.
And if you see where those numbers come from, I got to try something. You know, for example, you know, maybe 2 over 1, which is 2. But if I plug 2 in a box, because of the work I've gone through, you'll find a non-zero value over here. I just, in my mind, I try to choose one that seems to allow these things to go to 0. In my head, 4 seemed to be the appropriate choice, just because I'm familiar with numbers.
Can't you
You, on the other hand, might have a little trouble here. You'd have to try quite a few of them.
can't you just take a calculator and plug all the numbers through the equation
Yeah,
and see if they equal 0?
Well, true, that sounds like a lot of work. If you're going to use a calculator, I would have done this. I would have graphed y equals that garbage. See where it crosses the x-axis. It'll cross the x-axis seemingly at the tick where 4 is. Now, the calculator doesn't prove that it crossed at 4, but that would tell you to choose 4 from this list of numbers. It's just not going to do you a lot of good if you're, again, on a deserted island.
Or using a scientific calculator?
Even scientific, and it better not be a solar one.
Just to confirm, where did you get those upper numbers?
See, that was my first question to you. Because I think this. Sir, this is too important. So give me a minute. Do you guys think I can use this room? Can I get rid of this? You guys ever seen that mathematical statement before? Actually, it's such a nice statement, such an important statement, I'll give it a name. I'll call it the rational root property. Well, you mind if I take that back? It's not basically a property, is it? This is something I can prove to you is true. So I'll give it a different name. I'll call it the rational root theorem, because I can mathematically verify it. And the rational root theorem says this. You got a polynomial function in this darn standard form right here. If it does have a rational 0, and it might not, most of them don't, but if it does have a rational 0, that is to say, a 0 which is a rational number, say of the form p over q, then p and q as integers will have the quality that p divides evenly into the constant term, and q divides evenly into the leading coefficient. That theorem is so fundamentally important. If anybody wants to see me prove it, I'll take 2 minutes and prove it. Silence everywhere. Okay, but sir, now I'm going to show you where those numbers came from. My particular example I can't. I just erased it. guys, can you help me with this?
196.
Before I saw the x minus 4 times stuff, what was that equation right above that? Does anybody have no notes? It was a x to the 4th?
X to the 4, plus 28x squared, minus 225x plus 196 equals 0.
I'm so sorry. You sure that was it?
Yes.
Yeah, wasn't there one above it?
Yeah, that's the original,
That's the original.
and then there was x minus 4.
Gotcha, you're right, I agree with that, Yes, yes, yes. So, sir, I think this is my P of x. Where the a sub naught is 196. The a sub n, or in this case a sub 4, is positive 1. And so I think my P over Q is going to be a fraction where the p's are simply the factors that divide evenly into the constant term, the 196. And certainly plus or minus 1 divides us evenly into 196. Plus or minus 2, plus or minus 4. And what would come next? 3? Did I miss 3? Sorry. And then, you guys just don't want to play at all. How do you know 3 doesn't divide evenly into 196 so fast?
Calculator.
Because
Not a calculator.
3 doesn't divide into 16.
Thank you. Because when you sum these digits, you get a whole number that's not divisible by 3, therefore the 196 isn't. But 6 does.
Oh.
No, 6 can't. If 3 doesn't divide evenly in 196, 6 doesn't either. What about 8? I really don't know the answer to this question.
No.
So I do have some other values. Can I skip the rest then? Can I just go all the way up to the last one, which is plus or minus? But my Q is simply a number that divides evenly into leading coefficient, and as an integer, I think I only have 2 choices.
Could you repeat that once more?
Yes.
It divides evenly into both,
Q is going to be dividing evenly into leading coefficient of x to the 4th.
and that's only one.
And it's only plus or minus 1.
Right.
I'm looking at integers, they could be negative. So that's where I got my choices. And I admit, out of thin air, I said, let's try poly. Anybody else? Okay. But sir, have I answered all your questions? There were a couple more, I thought. Okay. Oh, it's okay with you guys if I don't finish? Yes. Thank you. Oh, let's see if I have something a little more interesting. I hope the graph turns out nice. It better.
How do you punish math?
What's that? How do you punish math?
Yeah. You said it better. It's in your head, you're going to punish it in a way. So do you guys think with this example, can I just cheat a little bit this time? This time, can I pull out my nifty little graphing calculator? Do we all have graphing? Do we all have T83s? Do we all have T83s? No, the answer is yeah, we do. Piece of cake. We can all just walk to the math center and do what I'm doing, right? Or a virtual calculator. So, having said that, I'm going to go into my equation editor.
I'm gonna type in the first equation, which is 12 sine squared of x. I said 12 sine squared of x plus 11 cosine x. I'll also type in y equals 14, I think. What should do next?
Graph.
I think even for both of those I should. Check mine. Thank you, I think I really should. Since I'm dealing with real numbers, I have to dive into my mode, make sure this calculus in degree and radian mode. Oh, it is. But I seriously have to check that. I don't know what's been in here before me. And now when I graph, yikes. What do you have to do?
Is that your window?
I think I should. So going in the window, I'll have an x min of like, I don't know, negative 0.5. I'll have an x max of, well, it looks like it should be pi halves, which is approximately 3 halves. So how if I go to 2? And I will have my x min to be, I'm not sure about this one. Can I just choose like negative 5 to 20? I'll change if it's too big. So there is my trigonometric function. There is my horizontal line. Shoot, you guys, I don't see it very well. So I dive in further. Let me dive in so that I see y values that are closer into the 14. And x values hover around 1. So how about this window? Have some y values between something like, how about 12? 16. And how about x values like between 0.7 and 1.7? Let's see if that gives you a better image. I'm being honest, I don't know if it will. Ah, it does. And so I guess I've got a bounded region right in here, where clearly is that trigonometric function that's on top, that linear horizontal function that's on the bottom. The only thing I have to worry about now is finding those points of intersection. To find those points of intersection. What do you do?
Set them equal to one another.
Okay, but I'm too far away. Do I have 12 sine squared of x? Plus, is it 11 cosine?
Yep. Equals 14.
Is it equals 14?
Yeah.
I'm waiting. I'm good at waiting.
Maybe rewrite sine squared of x in terms of cosine.
Nice. I got so close to having quadratic expression left hand side. I'm almost there. So to convert the cosine to a sine, what do I do?
You do convert sine squared of x
Would it
to
be easier to
cosine.
convert to cosine?
I think by far it'd be a lot easier to convert sine squared to cosine squared because I just had to evoke my very first Pythagorean enemy. We all remember trig, right?
Yes.
Does that give me 12 cosine squared of x? Minus 11 cosine of x. Is that a positive 2?
Minus 2.
Yeah, minus 2.
Isn't it 12 minus 12?
12 minus 14 would be negative 2.
Oh, I know, but I wanted a positive leading coefficient. I just changed every signs.
Oh.
Is that okay? And let's see when I check out whether or not this particular trinomial factors nicely. Clearly the 2 is going to be this one. What about the rest? Is that going to be a shoot? I don't know what's next.
I got you.
I'm serious. I don't see it.
I would just use a substitution, just make cosine squared x equal to the variable and then figure it out.
The answer
Yeah,
is
I know. I was just hoping to factor nicely.
2/3 and 1/4 is the answer.
Isn't it?
Both.
Oh, you're right, you're right. Is that a 4 cosine x? I couldn't factor in my head. Is that a 3 cosine x?
Yes.
Yes.
Yeah, I do agree with that, and both of them are going to be negative, aren't they?
Yep.
I gotcha. But that necessarily implies that the cosine of x is equal to 1/4, or the cosine of x equals 2/3.
that applies x is equal to,
Inverse cosine,
inverse cosine of 1/4.
1/4.
Or over here, x is equal to,
Inverse cosine 2/3.
very nice. Nobody there? If you are, let's set up our integral. In setting up our integral, I think the area between those two curves is going to be the integral between, ranging from, the low x value to the high x value. What's next? It's nice you guys allow me to take a break.
Or take,
Put the functions and
yeah.
subtract them from each other.
Do what next?
yeah, the integral of 125 sine squared x plus 11 cosine of x minus 14.
I think I need to fix a mistake first.
Oh, you need to,
Look at the unit circle. As I range from 0 to pi half radians, tell me how the cosine values are changing those angles.
They don't.
They do. As I range from 0 to pi halves, the cosine of all these angles do what?
increase?
I can't hear you.
Increase?
I can't hear you.
Go to,
They decrease from, I feel so alone again.
From 1.
From 1 down to 0. Do you guys see my point?
Yeah.
And so tell me what's changed. Changed the position of the upper and lower bounds of integration. I think the lower value, the lower angle, really has the inverse cosine of 2/3. The larger angle has a cosine value positive 1/4. Did you guys see my point?
No.
How about this? Here's the x-axis. Here's the y-axis. Here's the unit circle.
Okay.
Now, for an arbitrary angle theta, the point on the unit circle associated with theta has coordinates that are the cosine of theta comma the sine of theta. I'm just asking you this. As my angle theta ranges from 0 to pi halves, aren't the x-coordinates, these points, decreasing from 1 down to 0?